Hello everyone, welcome back to the lectures. In this lecture, we are going to talk about the NumPy library. The NumPy library in Python is a linear algebra library, and it is also one of the most important library for Python. And so if you want to calculate the vectors and matrices in Python, you will need this NumPy library. Let me type the title here. So this is our lecture 11, and we are going to make some NumPy tutorial here. Okay. And how you can use NumPy, the first step is that you should import the library here. In our Python, we have many libraries for Python. The first step is all the same. You should import them first before using them. So the name of NumPy is NumPy, and we will import it as MP. Usually we do this because some library has very long and complicated name, and we don't want to use those long names, so we will give it a short name, just as MP here. So we will use MP to represent NumPy in the following codes here. And firstly, let's start what we know. We have known that how to create a list. Maybe we have a list, my list. So we create the list by the square bracket, and we have several numbers here. So this would be a list. And the variable, the name is my list here. And we will change this list to the ND array by using this NumPy library. This is how we do it. So here, this one is a list. It's not a vector. We want to use the NumPy to change it to a vector. And let's give it a new name. That is a new my list. We will do a thing like this because we have imported the NumPy library. We use NumPy first, and we use a dot and dot array. So this array will change the list to the to a vector, and we will put this name here. Okay, so if we run it, nothing happened because we just changed this list to a ND array to a vector, and we give this vector to the new variable my list. If you want to say it, we need print new my list. So we can see this one is actually a vector here. So we can check the type of this new my list, and we can see that the type is not a list anymore. So if we check here, this one my list, so you can see this type of this one is a list. But here, if we use this ND array, numpy.ND array, it has been changed to numpy.ND array. This one has been changed to a vector actually. Okay, we can also create a matrix here, and maybe my matrix equals. We will also use MP array, and we will do something like this. We have a list, and this list inside of it, it also has some list. So this would be the first row, and this would be the second row, and this would be the third row. So this one will give you a 3x3 matrix, 3x3 list, and you have changed it to an ND array. If you run this, and you can see this matrix you just created. And you can see this is an array now. It is array means it is in our library, in our NumPy library, and it is a matrix. So here you can see it's 3 by 3 because you have put 3 rows here. Okay, and you can also check the type of my matrix. So the type is the same. So here is also a NumPy in the array. So this one is also in the array. This one is 3 by 3 and this one is 1 by 3 here. And you can also check the shape of this matrix here. You just you can use my matrix and dot shape. It will give you these two numbers. So you have 3 rows and you have 3 columns. So it's a 3 by 3 matrix here. Okay, let's then talk something about how can we create some vectors or matrix by using some built-in functions in NumPy. And suppose we want to create some vectors. We create vector 1, and so this vector is just one, is just 0, 1, 2, 3, 4, 5, something like this. So we can do this by using np dot arrange, and in this one, in the bracket, we will give you some inputs. Firstly is the start value, and the second, for example, we'll give it just like this. So this one means it will give us a vector that is started from 0, and then we have 15 elements, but it will go to 14 instead of 15 here. Let's see. We can show them. Let me check here. I think I have typed another R hack here. Okay, if we do something like this, so you can see this vector is one row. It starts from 0 and it goes to 14 instead of 15. So this is something you should pay attention. And another one is that you can see the increment is 1 because this is by default. There is another input here is 1. So this one is default. We can ignore this. And if we type it, it will give us exactly the same result. So this is the same. Okay. If we want to create another one, let's say we want to change this one, change it to 2. So this one will change the increment to 2. You can see that we start from 0, but instead of going to 1, we go to 2, because this one we set the increment is 2. Okay. And we can also create some 0 and 1s vectors, such as np dot zeros, let's say 4. It will give us a vector that contains 4 zeros here. And we also have ones. And for example, if we want to have a matrix that contains the elements that is all 1, let's say we want to have a 4 by 5 matrix, and all the entries inside the matrix is 1. So we can do like this. So you can see that it will give us a 4 by 5 matrix, and all the elements are 1. Okay. And you can play around these codes here, and I will go to the next code. And we can also have the Linspace. We can use something like this. We can use this one, Linspace. We will give some inputs here. So you can see it asks us to give it some inputs. The first one is the start number. Let's say it starts from 0. And then second input is the end number. So we want to have some numbers that is from 0 and it ends at 15. And we want to have 5 linearly spaced numbers that starts from 0 and to 15 here. Let's see what happens. So you can see it will give us a vector that is started from 0 because you give it to 0, and it ends at 15. So you can see it ends 15, and it has 5 elements. 1, 2, 3, 4, 5, and these 5 elements is evenly distributed, and this is why it is called Linspace here. Okay, and let's try another one. Linspace. Let's say 0, 20. So this one from 0 goes to 20, and you want to have 9. You want to have 9 numbers here. Because here we have 9 numbers, so there will be 8 intervals. So each interval you use 20 divided by 8, you will get 2.5 here. So this one is also the same. We have 5 numbers, so we have 4. So we have 4 intervals. In the range of 15, if we want to have 4 intervals, it's 15 divided by 4. It's 3.75. So this is how it works. Okay. And okay, we can also ask our Numpy to create some random vectors or matrices here. We can call the random numpy dot random and dot rand, and let's see 3. So this one you can see it will create 3 elements here because you give it 3. It's a vector, but for those numbers it's evenly it's a uniform distribution from 0 to 1. So you can see there's no elements that is greater than 1 or less than 0. It all belongs to the interval of 0 to 1, and it's a uniform distribution. So it means that the probability of each number is the same here. And if you want to create 2 larger intervals, for example, from 0 to 3, you can just multiply by 3, and it will give you larger numbers here. Okay, you can change it to 5. It will give you 5 elements, or from 0 to 3 here. And we can also ask this function to give us some random matrix. And let's say 3.5. So this one will give you a 3 by 5 matrix that contains the elements from the uniform distribution from 0 to 1. You can see it will give us a uniform distribution numbers, and it is a 3 by 5 matrix here. Okay, and this is to call the uniform distribution. Sometimes we also want to call some numbers that is from the standard normal distribution. We can do something like this. This is also the same random, and the rand n. We have a rand n function here. So this n means normal distribution. And let's also do the same thing, just 3. So this one you can see it also gives us a vector that contains 3 elements, but this time these numbers are different. Now we can see we have some negative values, and we have some values that is greater than 1. So this means the mean or the average of these numbers is 0, and the variance of these numbers is close to 1 or equal to 1. So so this rand n it will give us some numbers that is randomly distributed from the standard normal distribution. So in standard normal distribution, the mean is 0 and the variance is 1. And we can also create some metrics here. So we can see we created a 3 by 5 matrix, and all these entries is coming from the standard normal distribution. Okay. Okay. Sometimes we can also change our vectors to the matrix here. Okay. Let's show you. Let's say we have create a vector that is from this arrange function, and we start from 0, and we end at 29, because this one will not get 30 for us. Okay, and so this would be a vector. So we can see that it gives us a 1D array, that is a vector here. So what if I want to change this vector to a matrix here? We just do a very simple thing like this. I will call this variable my vec, and we will use the reshape. So this reshape means that I will reshape this vector into whatever you want. Maybe we want to reshape it to a 5 by 6 matrix. Okay. So you can see that it changes this vector to a matrix, to a 5 by 6 matrix. So you can see it has 5 rows and it has 6 columns here. So it's a 5 by 6 matrix, and we can give this matrix to a variable. Let's say this is my matrix 2. Okay, we run this again. And what if I want to take the transpose of this matrix? So what you need to do is just my matrix 2, and you call transpose, and you give it a bracket here. So this one, you will make the transpose. Let me. So you can see that these two matrices are transposed. This row goes to this column, and this row is the second column here. So you can use this one to make the transpose of a matrix here. And in our ND array, similarly to the list, it is also all these numbers have its unique index here. And seeing it another way is that we can find any elements inside of this ND array by its unique index here. Okay, we can start also from a very easy example. Okay, we will firstly create a 1D array. By this arrange function, and we just need 20 elements here. So this one will give us a 1D array from 0 to 19, which contains 20 elements here. And so all these entries or elements has its index, and all the index begins from 0. So this element is 0, and its index is also 0. And this is 1, and its index is also 1. And if we want to find this element, we need firstly see what is its index. So this one, this is just a coincidence, because this 0 is also its index. So if we want to find this 10, we just do something like this. We'll use a square bracket, and we input the 10. So this is the index. And so here you can see it will give us the 10 because so this 10 would be the elements, this element. Okay. And what if I want to find the range of the, for example, this one? Okay, we will do something like this, my back square bracket. So what if I want to find from just 2, 3, 4? We will use the index of 2. Index of 2 is 2. We put a column, and index of this one is 4. Okay, so so this one it will not get the 4 element. If you put the index here, it will start from 2, and it will capture the 3, but it will not do. It will not get the 4. If you want to get 4, you need plus this, plus 1, and so this one you will get 2, 3, 2, 3, 4 here. So this is something you should pay attention. Similarly, if we would use -1, so this means we will get the last element here, which is 19. So you can see it gives us the 19 here. So -1 means we select the elements from the back. Okay. And next, let's do something like this. We also use this myVec. We firstly create a vector 1D array, also by this arrange function, and we print it out. So this one, you can see it gives us a vector like this, which contains 15 elements, and we want to do a slice, and I give it a variable name, just like this. So I will slice this 1D array. It means that I will take some elements out. It should be this one, myVec. Okay, myVec, and I will put maybe from 0 to 7. So here, so I will make a slice like this. I want the elements that is from the index of 0 to the index of 6, right, instead of 7, because this one will not get the index of 7. So this one will give us the element of these elements here. So if we want to say, so you can see it gives us the ND array from this one, but we just get the first 7 elements here. And then I will do something like this. If I put just one column, here, it means I will index the entire 1D array, because I put nothing here, so it will start from the beginning to the end, which means all these 1D array. And so this means I will index them all, and I will change them to the number of 20. So it means I will change all these elements to 20. And let's see what happened. You can see if I give them a number of 20, these 7 elements are all changed to 20. So it is changed. And you can see this slice vec, this variable is highlighted here. So this vector is a slice from this one, from this myVec. So we can see what happened to this original vector here. Let's just print it out, myVec. So we can see we just make a slice from this original vector. We changed its entries, but in the original vector, these first 7 elements are also changed. So this is something you should pay attention if you use a slice and you change the numbers, and the numbers in the original vector is also changed. Okay, it is correlated or connected here. Okay, this is some index in the 1D array. So in the 2D array, which is a matrix, we can also do some index here. Let's create a matrix firstly. Okay, we will first create a 1D array, which is a vector. Okay, we have 30 entrants here, and we change this vector to a matrix by using the reshape function. My vector dot reshape, and we will change it to a 5 by 6 matrix, and let's see what happens. So this is my vex. So we can see we have 5 rows and we have 6 columns. So this is a 5 by 6 matrix, and we will index this matrix here by using some numbers. Firstly, if we want to index the first row or the second row, and the number of rows is also by index. So the first row, the index of the first row is 0. So remember, all the index in the Numpy or starts from 0. So this is although it is the first row, but the index of the first row is 0. Let's try. So if you can see, I just put 0 here. It will give me the first row, which is 0 to 5 here. If we change it to 3, so the index 3 is the 4th column. So it's this column. You can see it is changed to this column. Okay, what if I want to index the column here? So here I'm indexing the row. So if you want to index the column, you should do something like this. We put a column here, and we put for example 1. So for this one, it means, so this one, it is indexing the row number. We put nothing here, so here it will index from the first row to the last row, well, which is the entire matrix here, right? And this one is indexing the first row to the last row, which is the entire matrix. But this one, so this one means the index of the column here. And this one is the index of 1. So the first column is 0, and the second column is 1. So here it is it will give us this column, which is 1, 7, 13. Here, let's see. You can see it will give us this column here. And if we change it to 3, and so it will firstly go through all the rows, and then it will, for all the rows, it will give us the index of 3 of each row. So in the first row, the index of 3 is 0, 1, 2, 3 is this element. And in the second row, the index of 3 is this element, and this element, and this element, and this element. So, so here we will get this row, the 4th row. You can see, right? We get this row. It's a 1D array. Okay, this is how you can index the column here. Okay, what if I want to get a specific element here? We can do something like this. Also, we call this variable, and we let's suppose we want to get this element, and we will see the index of this element, the row. The row is, this is the second row, but the index of second row is 1, right? Because our index starts from 0. And so by doing this, we are indexing this row, but we need to locate this number, this 7, and we need to also index the column here. And so for 7, the index of 7 in this row is also 1. So you can see it will give us 7 here. So if I change it to 2, it will give us this number. You can see it will give us the 8 here. So all the numbers can be indexed here. Okay. So what if I want to make a slice here? What if I want to make select some part, just some parts of this matrix, not the entire matrix? Okay, we can also do something like this. We put a square bracket, and let's say we want to get this numbers and this number, just this. That's it. We want to get this one and we want to get this one. Okay, if we want to get this one and this one, we need to firstly locate the rows. So this one, the row starts from 0, and we put a 0 here, and so the next one we will put a 2 here. So it will goes to the index of 2, which is this row, but it will not get this row, just get this row. Okay, and then we put a comma here, and then I said I want to we want to get these numbers and these numbers. So for this one, we have selected the first row, and for the columns, and so the index would be from 0 to 3, right? Okay, let's see what happened. Okay, for this one, it will also not get these 3. If you want to get these 3, you need to add 1. So this is something you may forget, because for this one, it will not get the number of this 2 or this 4. It will get for this one, although you have indexed to the index of 2, but you just have the first 2 rows. And for this 4, if you want to have the although this is index 4, but this index of 4 is not included. So this one is the index of 4, but this is not included. It just gives you the first, this is index 4. It will just give you the first 4 elements, and this will not be included here. Okay. And this is some part of can easily confuse you. Okay. And I think that's all I want to cover in this video. And I have introduced something about the Numpy library in Python. And this library is also frequently used in machine learning because we will do the calculations based on the vectors and the matrices. Okay, I think that's all for today's video. Thank you for watching. See you next time.